All right, happy Monday morning. Today we're gonna, send you off to college next year, and here's the idea. If you follow along with the notes, you go into school that costs you $30,000 a year, you do that for 4 years, $120,000 that you've got in the bank. Well, no worries, I've got you covered. I will loan you the $120,000. I've got it right now, no problem. I'm happy to help you out. So I'll loan you $120,000, but you got to pay me back 30 years from now. I'm going to charge you just because I could take my $120,000, put it into the bank, and get a 5% interest on different investments over the next 30 years. I do need that from you. How much are you going to owe me? Well, if we've got $30,000, compound interest, let's do this monthly for 30 years. The end of 30 years, nope, I don't want $30,000, I want $120,000. That's how much I'm going to give you to help pay for school. So we're going to do that for 30 years. Not so bad. Don't have to worry about it right now. You'll pay me later. So we'll plop it in compound interest formula. That comes out. Your school does not cost you $120,000. You're going to end up paying me $536,129.32. Yeah, that seems a little bit unreasonable. Here's the idea, is that the way student loans work is they lend you some money right up front. You've got a certain amount of time to pay them back based upon the balance. If you owe $120,000, let's hope that you're going to have 30 years to pay that off. It all depends upon your income. It depends upon the repayment plans that you have. You are not actually expected to come up with $536,000. What's going to happen is you're going to make monthly payments. That's where the systematic savings comes in. You are responsible that the bank is going to loan you money 30 years from now. They're going to expect a total value of that $536,000. You are going to end up paying a different amount each month. Times 30. We've got our systematic savings formula. And then, so the way it's going to work out is that's really the final amount, the full amount that you have to owe. You can work backwards and figure out how much that you end up paying each month so that in the end, it covers that. Now you've covered the principal, but you're also paying a bit of interest in there. This is what gets us to the idea of an amortized loan. The idea behind an amortized loan is I loan you some money and you're going to pay me back the same amount each period of time for a set time period at an interest rate. What we're going to do, we're going to combine compound interest. You're borrowing money. I expect a return on my investment, but you're also paying that is going to get you the full amount. So what we're going to do is we're going to combine those two, compound interest and our systematic savings. You're going to pay in incremental steps. The bank gets the full amount. So let's figure it out. So combining these two, we're going to create the amortized loan formula. Now taking this, we're going to solve for P. It's just a matter of, if we divide this, we've got P equals and looking, well, we know that's the same thing. We need to distribute our division there. So we're going to divide this by this. That gets us 1. Well, subtract 1 divided by this. 1 over something. We can rewrite this. It's 1 now minus 1 over gets us a negative exponent. That is correct. It's a negative nt in our exponent. What happens is if you pay this amount each time period, we've got an interest rate, we've got the number of time periods that we're paying each month or each year, the number of years gets us the principal of the balance. That's what we want. So if your school costs $120,000 over the next 4 years plus, you're going to end up paying a principal of $120,000. We can work through it, come up backwards. So what we have here, this is called the amortized loan formula. the amortized loan formula. I swapped out R for D because you are repaying now. It's repayment, you are paying back rather than saving, rather than depositing money. So deposit, systematic savings, you get a full amount, a final amount. Here we've got a repayment amount. You're going to find the principal value. So we've got our amortized loan formula, where P still stands for principal. R is our regular repayment amount, how much you pay back each period, and the number of annual repayments, same thing. R is your interest rate as a decimal. Time is in years. T, time is in years. So we have our amortized loan formula. So we're going to go through, look at a couple examples. There are 3 different things for which we can solve working with this formula. We can solve for P, find the principal that is reasonable if we know our monthly payment. If we know our principal, so if we're going out and purchasing a car, we can find out how much we have to pay each month or so. And we can also solve for T. Just like with savings, we cannot easily solve for N or R, so we're going to avoid that. We're going to solve for R, P, R, and T. So I'm going to use the examples in the notes going through this. We're going to see how it works out. So first off, we've got our formula. We're going to find P. So this first example, college senior does not have enough money. I know how that goes. So if you need to borrow some money to float through school, you have a home loan, a car loan, a personal loan, a home equity loan, any kind of loan where you're borrowing money. You can sometimes, now here's the advice is, often we go out and we buy something without thinking how much is it going to cost us. But on the other side, here's example 1. We know that we can make quarterly payments, so N is going to be 4. We're going to be doing this for 6 years. We have an interest rate of 7%, so that is 0.07. We can afford, so I can pay back $360 every quarter. I know what my budget entails. How much money can I borrow? So this is the idea of, this is what my budget I can afford, this is how much I can pay. This is a reasonable amount for my loan. Going to go to the formula. We've got P equals R. Notice that I'm using separate types of parentheses. I use the square brackets to indicate everything there. In the calculator, you're just going to put it in as normal parentheses. We've got 1 minus 0.07 over quarterly over 4 to be negative. Don't forget the negative exponent. 4 times 6 all over 0.07 over 4. Very similar to the systematic savings formula. Works just the same. We know that this is $360. So it's a matter of, we have everything on the right side of the equation. We can just plug it into the calculator and go from there. So, evaluating, we've got 360. Now, my calculator, I could plug it in all at once, so I've got, there's the compound interest statement, negative exponents. If you do not have the, if it shows up with a caret, make certain you put parentheses around that and arrow out. There's the entire top divided by entire bottom. So if I can afford to repay $360 every quarter, so that's every 3 months, the most amount of money that I should be borrowing is $7,005.85. We can find a reasonable principal that we can afford. All right, next, finding R. We're going to go to example number 2 out of the notes. We're going to purchase a car. Now, our car costs us $16,000, 32 and 31 cents. So we've got a principal on the car. We're going to make a 10% down payment. Now, this is often how things work. If you go out and you make a purchase, they don't just give you the car, you show up. They need a little bit of money up front to make certain that you're good. So you often have a down payment on either on a house or a car. You offer a down payment first. So what that does is it takes a value off of the principal. So if our entire car costs $16,032 and 31 cents, 10% of that is going to be $1,603.23. We'll subtract that. We get our principal, actually the amount of the loan, $14,429.08. So our car loan that we have here, we've got a 10% down payment. We're going to make, we've got a loan 7.9% interest payments compounded monthly. And our loan is going to be for a total of 4 years. So I can take this, plug this into the formula. I'm going to rewrite my formula just so that we can see it again. We know the principal in this case. We know our interest rate. We know how often we're making payments. We know for how many years the loan is worth. We want to figure out what is our monthly payment. So you're going to a car dealership. You're going to make a home purchase. You're going to buy something. You want to know, can you afford it on a monthly cost? So you want to figure out how much are you going to be paying each month. So we'll substitute everything in that we have. We've got the final principal for the loan less the down payment. We're going to be solving for R. We know the rest. It's negative 12 multiplied by 4. Running out of room. Now what I look at is this entire piece we know. So we can do all of that multiplied by R equals the 14,000, and then we will divide by all of that. I'll substitute that into the calculator altogether. We have up top there's our top, our numerator. There's our denominator. We have I'm rounding to 3 decimal places. So we have 14,429.08 equals 41.041 R. We'll divide both sides by the R, by the 41.041 to solve for R. So we've got we get R equals $351.58 per month. So we've got a car loan, $14,429 total. With that interest rate over 4 years, we're going to end up paying $350 every month. One more kind of extension behind this. If we can figure out our monthly payments, we want to figure out what's our total cost. So let's do one more example behind this. Going on to number 3, we're going to find the total amount paid, not the principal, but the total amount that you pay along with the interest. So I'm going to go on to number 3 here. Back at the beginning, we are taking out $120,000 in student loans because, well, we decided to go to one of those schools that costs us 30 grand a year, even with financial aid. If we still need to take out $120,000, let's say we have 30 years to pay this off. We're going to be making monthly payments, and I said at the beginning that's 5% interest. The one thing we don't know is our regular monthly payments. So how much total do we pay, and how much of that is interest? Now, we are getting $120,000 worth of schooling. Hopefully we get that much out of our schooling. If we want to figure out first what's our repayment, our monthly payment amount, we're going to use the formula. Careful with the negative in the exponent. So all of this we can evaluate. we get 120,000 equals 186.282 R. Solve for R. We'll divide both sides by that value. So you are on the hook for $644.18 each month. You got to pay that back. So there is our monthly repayment amount. Our total paid. Think about this. We are doing $644.18 every month. There are 12 months in a year, and we are doing that for 30 years. So the total amount that we kick in, 644.18 times 12 months in a year, times 30 years. Take that value, multiply it. You have paid a total of $231,904.80 for that school. So this is over the course of 30 years, yes, but you've paid, that's almost twice the initial value of $120,000. So the total amount that you pay is your regular payment multiplied by the interval multiplied by the time period. And lastly, our interest. Our interest is the full amount, subtract the principal, gets us our interest. So we've got $231,904.80 that we are paying. Subtracting $120,000, that is $111,904.80 in interest. Now, interest, the idea, that's money that you're just paying away, borrowing it. So this is where banks make bank, so to say, because that's money for free that you're just paying for the ability to borrow money up front. Now, hate to say it, that's a reasonable number. Those are reasonable amounts if you are opting for one of those schools. So it's time you're making those decisions. Be careful. Think about the finances. Don't make a decision before you actually crunch the numbers. Personally, my brothers, they went to school, they racked up a lot of debt. They came out, majors that did not pay. So now they have more jobs, more debt, and all the money didn't really kick in. So you got to think about, is it worth it? Is your college major actually going to pay the bills? So try out the practice. There's a few of those, working through those. Check this out. See you tomorrow.